Sorry for my, I was blocked on traffic jam. Okay, hi everybody. I will speak about Iteratee. Just before, for people who don't know, this is my day-to-day job. In fact, I'm working for Clever Cloud, and we keep online a lot of application, in particularity Scala application, Play application, not .js application, a lot of things in a Heroku way, but better and be by nicer people. So, and we learn a lot of things about all people code. So this is why we show a lot of good practice, bad practice, and good design, bad design, things like that. The first thing I want to speak with you is why streams are so trendy today. Because if you are in the main room yesterday, I think we have lots of talks about streaming, reactive streams, and a lot of things like that. And many people are speaking about streamings, but just a few people are using it. There are two main reasons why streamings are very popular today. The first thing is data are coming bigger and bigger. So if the data is coming bigger, fat cat, internet. If the data are coming bigger, we have a problem because we have to make something while people are uploading or downloading their data, because they cannot wait. We transfer all the data. We need to act when the data is occurring. Okay, when the data transfer is occurring. I don't know where is the no GIF in this slide. Okay. The second part is we are using a lot of permanent connection. Who have read the draft of HTTP 2? Okay, I know it's the weird thing of hosting provider. We like to see what is going on. And the main part of HTTP 2 is how to maintain the connection between servers and clients all the time to be more faster. We have server-sent event, we have WebSocket, we have a lot of things with push information bidirectional between the two things. So right now, a lot of things about streamings are based on the two reasons. I give you an example based on the first reason. If you are thinking about why there is no GIF there? If you are thinking about an HTTP request is verb, resource, headers, body. No problem for the three first things, but the body can be extra fat. And in many cases, we have framework that manipulate all the requests in memory. Ruby does that, PHP does that, not.js does that. The thing is, all the thing with people is they get the request and they analyze it. There is a problem. If you are uploading a 20 gigabyte file on post request and store it, you cannot wait the request is ended to load this, because it's a very bad idea to put this in the memory. Very bad. There is another way you can do that. You can create a temporary file store for storing the data. In fact, the one thing is you can lose what is the servers where you are connected before. So if you store the file system and it's another servers, it will have a lot of problem. And there is another reason is if you upload the file, then create a temp file, then send the file in a backend to store it, then answer to the customer, it's not so good. And I have a very big problem with my GIF, because all the GIF was there just before PowerPoint by Microsoft. And the other thing is, if you can upload the file, directly stream it to the backend, then answer to the customer, it was very, very better thing. So we have to act on stream. When you are doing some classic Java stream management, you are doing this kind of thing, with a while blocking in the read, and you're writing an output stream in something. The problem with this kind of thing is you have to do something about performances, so you put buffer in this kind of code with buffer management, exception, overflow, a lot of problem. And there is a big problem for me. It's you are mixing the IO stuff with your business code. So this kind of code make me crazy. There is low performances. It's not modular at all. It's thread blocking, so you have to manage your thread pool yourself. The code is practically unable to be read by a human. The back pressure, forget it. The error handling is, okay, it failed. And the IO management is totally imbricated with what we are doing with the data. So when I put some code like this in production, I can sleep in the night. You know, this feeling when you're putting some code in production and saying, okay, I'm pretty sure it will crash, but I don't know when. So we have to find a better way. That's why we need Iteratee. In fact, Iteratee adjusts data structure to express data stream management. Iteratee is simple. The way people are explaining it is complicated, so this is why I will doing something very low and basically. If you're thinking about, you have the Iteratee. Iteratee is more like a recipes about how to manage the data, okay? It's not something you are active. You are doing a recipes and a data structure will understand how to manage the data, but it don't grab the data. There is no dot read. There is no buffer, there is nothing like that. You have an enumerator. An enumerator is just something we put data out there. It's a data stream. It produces all the data. It's simple, it produces data. And between the two, we have a weird friend with Enumeratee. Enumeratee is a very cool thing because it's the thing we can use to connect enumerator to Iteratee simply. Because in fact, you have a pipe, another pipe, and Iteratee does the plumbery. It just join, it's all the thing with that. Because Enumeratee is part an Iteratee, consuming an enumerator, and an enumerator for piping data into an Iteratee. Okay, simple example to start. First, we will create an enumerator, okay? This enumerator doing something very simple. We take all the words of the first paragraph of the reactive manifesto and choose one by random and emit it, okay? We have a very simple Iteratee. The Iteratee is there, so just taking 2 minutes about that. An Iteratee is just something we can take input. In fact, input can be end of the stream, empty things, or an element to manage. Okay? There is only the 3 way. And an Iteratee have just 3 states. It can be done, so it's okay, I finished my work. But I have this data I don't manage, optionally. It can be failed, and there is this data I don't manage, optionally. And I have still work to do. And this is just strike typing. If you are looking at the Iteratee we are working about, it's just something we do some word aggregation. If it takes 2 words, put a space between, and return the value. If the input is the done, so we say just input is down. If the input is empty, we say, okay, we have to step again, to see if there is something there. And if there is an element, if I have previously something, I have to stack the 2 words together. And if I haven't something, I just store it for my thing. And what I like with Iteratee is there. It's me will start the way that Iteratee will beginning their work. I say there is just a continuous structure from an Iteratee taking streams and giving streams, and he will step beginning with none and taking an input. So it's very simple to understand what is an Iteratee because you have all the thing. There is no dark magic outside. All is there. You have all the data structure there. Okay? If I take this Iteratee and put it in an enumeratee, the enumeratee I used is to say, okay, I will group the streams by this Iteratee and put it in another Iteratee with log stream is just an Iteratee for print all the things going in the stream. Okay? It's quite simple because the enumeratee just put the data together into an Iteratee will group two words and log this in the stream. If we have a look at the demo, we launch the demo and we see we have just two words each time side by side. Okay? The powerfulness with Iteratee is there. If I take an Iteratee and I change it, this one is qualified word, and I say I don't want a word more than 5 letters. And I stole the end of the word to make another word. So I will just chunk all the letters I take as words are just data, and I chunk it with words of 5 letters. The Iteratee is quite simple. If you can read it, it's simple because if this is the end of the stream, it's just done. If it's empty, you have to wait something interesting. And if there is element, if the long match, it's going. And if it's not, okay, continue with the buffer. If we're using it as the demo, we can see, okay, Scala combining. If we're using it, it will chunk all the data produced by the enumerator by 5 letters word. Which is interesting is Iteratee allow you to be composing. So if I get my first Iteratee to group data with qualified word and I put it in Iteratee called word aggregation, we join 2 words and stream this to log stream. What is interesting is I will use the 2 part code together very simply. Compiling. Yeah, I'm lazy. I'm doing some video for my demos. Not for the end of the talk. Okay, everybody understand how this works, or it's complicated? Yeah, I'm sorry about something. I put confusing operator there. It's a fish. The fish mean transform. I don't know why, but I like it because it's pretty. Yeah. In fact, enumeratees are much simple to compose than Iteratee because Iteratee are very strict about what they get, and enumeratee allow you to just change the type and the time you have to get, and so you put enumeratee side by side and compose it to make your program. So. No, it's doing by stream because if you are looking at the code I'm doing the first part, there is some done. So I release the data when it's ready. So the enumeratee can take it and give it to the next pipe. So this is why it's so powerful, because you haven't to wait. It's finished at the first part. It's pure functional. It's very type safe. And you have the composition. So, this is what is interesting for me, because I don't want to rewrite an HTTP parser. I have some work to do. And I just want to manage the body stream, not all the parts. If you are looking at the Play application, you have this kind of thing saying, okay, I want to put the data in a temporary file. You see? There. In fact, this place is the place where we are defining a body parser. And the body parser is something taking request header and giving you an iteratee, taking an array of bytes and returning either a simple result for error or whatever you want. Okay? This is what I do. I take a body parser to take a request header. I'll calculate the hash of all the chunk of data, and I print it. I return a list of string, and I print it there. Demo. I mean, real demo. Where is my IDE? Okay, we'll change of space. Okay, everybody can read? Okay? If I am here, I have my simple body parser with a body parser who can easily take the request header, and this is the things to calculate SH1 hash is not interesting, and I create an iteratee there called hash iterate, which in each step calculates the hash of something of the data chunk he gets, and put it in a buffer with the list of string we contain all the hash. And when it's done, it returns it. What's interesting is there, I have an action. The action called my simple body parser will be used as body parser, not all HTTP requests, only body parser. And the request say, okay, request body to string, because the body there is a list of string, because the body parser return the body parser is an iteratee returning either a simple result for error or a list of string. Okay? So all is type safe and self-contained. See if it works. Cool. I'm not sure of the road. Okay, give it a try. Okay, there. This is the answer of the code. If you are looking of what is there, it's the log of what we are doing. Okay, it's too long. I will take a bigger file. What I have, just a minute. Because I have a very big file there. Oh, sorry. kernel panic. PowerPoint and macOS, kernel panic. Okay, while my Mac is rebooting, I can take a question if there is a big question there. The question. What I am saying is clear, really? You can use it for infinite streams. I don't know. You can use it for infinite stream, but don't use flat map on play Iteratee because the flat map on play Iteratee is bugged and there is a big memory leak. But theoretically, you can use Iteratee for infinite stream. In fact, I use it for infinite stream at the demo because I kill the stream by killing the program. So you can use it for infinite stream with no problem. It's doing for infinite stream, but you can also kill the stream when it's down. Okay, so it's a mess. No, I don't want to speak with you, Mozilla. There is no my curl there. No, no curl. This is the time I need a big file to clearly show how it's working. Okay, this is big file. Kickstarter, please. Okay. Much bigger file there. Data binary, sorry. Okay, the curl is doing right now, and what we have interesting is there. If you are killing this at the beginning, we can show is the request was sending, and right now we're getting some hash. So we're getting the hash of the file directly. The thing is, if you are thinking about it, it's totally silly to get the file, the hash of chunk, we don't decide what is the size, because the chunk size is important to have the hash. Okay, so like we do with words just before, we can have a function called clarify chunk. It's basically the same thing than for words, but for data. And right there, I'm saying part size is about 5 megabytes, okay? It's basically the same Iteratee. If you are thinking about that, I'm just taking my simple body parser and say before that, I will clarify my chunk. enumeratee dot group, because it's a grouped action, and I so qualify chunk, and I say put it in hash iterate. Okay? If I relaunch the application, and if I relaunch the application, we see the chunk size is more bigger right now, but we have just qualified all the chunk by 5 megabytes. Okay? This is quite interesting because if we can do that, we have the control of the data flow and how many data my Iteratee or all the thing can handle. So it's a big file. It's about 2 megabytes. Go inside PowerPoint. Please don't crash again. Okay, we were there. Don't crash, don't crash, don't crash. Cool. If you want to use form, this is why Iteratee are so powerful, because they can love composition. So if you are using a form, who are doing a multi-part body parser one time, a parser for multi-part data? How do you feel about that? The worst day in my life, I think. This is why it's important, because Play gives you a part handler with basically a composition for the body parser. We are handling the multi-part system for you. So with this kind of thing, you can access to any part of the data stream in your Play application just by composing Iteratee between them using the enumeratee. Okay? So now we have access to the stream. And this is why it's important, because I remember the title of the talk was about data storage. I'm an hosting provider, so I have a problem. I hate file system. When I say I hate file system, I really hate file system. I beg you, do not use the file system as a data store, because you cannot scale the file system. You cannot share easily between several hardware. You cannot have something without SPOF in a file system. So we are doing something right there is we will chunk a file to put it in another data store. For example, we can stir a file chunking the file inside a key value store and using a hash as a key for the chunk. Okay? And if we have the metadata, we can have a list of hash for chunk, and we have all the file. Agree? So the process we have to build, if the file is parsed by the brother, because we want a fancy user interface, the stream in chunk and normalized. We take each chunk and store it asynchronously in a key value store. Take the list of the chunk and store it in for the file, and there is no overhead for the customer to bring it into a key value store. And there is a bonus: we can have deduplication in the block size, so it's cool. For the demo, I will use Play2 and Iteratee, and the data store is React. Because React is quite interesting for this kind of stuff, because you can launch hundreds servers in the single React ring and store petabyte of data there, and it's handling all the replication of the key and something like that. So you don't have to be preoccupied by the data safety. You have only to make the code. So I put the code with React. Not crashing right now. Okay, I have to launch my React. Um, okay. React start, React start. Okay, cool. How is it working? No, it's not readable for you. Uh-huh. Okay, I understand. I have to get out of this. Yeah. Don't crash, please. Oh, it's white. It's white. I crash again. Okay. I'm so sorry about that. I play with this demo all the morning, but it crashed on my machine when I'm on stage. I'm so sorry. I'm doing the demo, then I relaunch PowerPoint. Maybe. Two kernel panics is the same demonstration time. Not bad. No, 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 it's not. You're not mandatory, PowerPoint. Okay. Okay, how it's working? If you take the code source, you have only one controller. We have something quite simple. Bigger, yeah, sure. Bigger, no. Something like appearance, colorance, fonts. No, it's not there. Editors. Command Plus? No, I'm trying, but not working. Where is it? There? Size? No, it's not there. Font? Colors and fonts, okay. Basics? Where? Ah, yeah. Text font there. Edit. Okay. Okay. We have an index just viewing your HTML. It's okay. We have something I will talk about later. The action of uploading a file, which entirely rely on the multi-platform data part handler. With this, the body parser multi-platform data part handler, we allow you to have a non-dollar file part. So it qualify chunk, it group there, it put it in the data store, and after that, it prints a lot of things. And when the map is down and the stream is ended, it store the list of file. Okay? We can try it. Yeah, it will work. It's not made by Microsoft, so it's okay. Okay, fancy user application. I take a file, not taking a file. Crashing again, not crashing again. Can I have my application synced or not? Ah, it's Firefox, okay. That's why. Firefox don't want to do that because it was closed unsafely, blah, blah, blah. Okay, I take a file, for example, the Dancing Obama, and I put it in my data store. Okay. And if I'm trying to get the file is there. Okay, it was easy. It's not big data management, okay? Taking a file and we can work with this video. Okay, we put in the file, we see the transfer is occurring, and we have a key there. What is interesting, if we are looking at the backend, if there is all the file tree, there is a list of all the hash we will put inside the React backend. Okay? And if we take this and we put it, for example, in VLC, yeah, I know. I'm looking for crash right now. Yeah, sure. The video is streaming perfectly. Cool. It's working. We are getting all the chunk side by side each other and putting this into the stream of the answer. And what is interesting, we can do this with much bigger file. So just stop it, and I will show you how we can get that. Uploading this file, big file, okay, a half a gigabyte, and is it uploading, and you can see there. The thing is, when we are retrieving the file, what we do is first we fetch the list of hash, then we just putting some Java there, and we have a chunk feature. And what is very interesting is we do an enumeratee, getting all the byte of the thing, and the enumerator say, okay, get all the ID, put it in the chunk feature, and the stream is the data contents. The data contents is just the enumerator of an enumerator. In fact, we build an enumerator with all the list of the file, and we put it in an iteratee, retrieving an enumerator of data with basically all the data of the file, but it's an enumerator. And there is something very interesting with play, is if we are taking an enumerator and put it in the answer, play chunks the answer to the browser. So the stream of data begins directly without finishing. So you can stream data from your database directly with play, with HTTP1 just chunking transfer. So very powerful. So we are chunking, yeah. Maybe last finishes. And if you are looking at something like that, is all we are doing in data management is about hundreds of lines of code. So it's very small. It's not complicated. And it's very reliable. It's never failed in production, in fact. Okay. Are we ready? 80%. It's a video interesting for this kind of test because the video is about 1 minute long, but it's a very of half gigabyte. So there's a lot of data to stream back to the clients when we want to play it. So this is why it's interesting to do it. Okay, 100%. Deal, not deal. Cannot panic. No. And the video starts directly, but it's a 1.5 gigabyte video. So this is quite interesting to see that because it's now we can now directly store data from the request post to the results. Okay, I'm late. Cannot panic, things like that. So. I have to finish my show quite directly. So, are you convinced to use data stream? No, not right now. I have to make a point about something. Yesterday, you can see a lot of things about reactive stream. We have a lot of stream about how streaming will be made in Play when it will be 2.4 and Play 3. But right now, reactive stream is at the beginning. So right now, if you want to do some streaming, use the Iteratee. The way reactive stream are thinking is not functional. It's not purely functional. It's an idea of unification with the people of Java and Groovy and all this non-functional language. And this is why Iteratee is not the standard for everyone. And the other part is because nobody understands Iteratee. And what is interesting is you can re-implement Iteratee in top of reactive stream and get the type safety of Iteratee on top of that. The other way to do interesting streaming in the Scala world is the Scala Z stream, very powerful, and get something very interesting is the ability to be bidirectional, because Iteratee and enumerator and things like that is not bidirectional. It's a problem people have with Play when they are doing WebSocket, because you have an enumerator to send data and you have an Iteratee to get the data, and it's complicated for people. But basically, you have the three possibilities on top of the same thing. What is important is to have streaming doing quite good in the bottom of the JVM, and after that we can use Iteratee, you can use reactive stream, you can use Iteratee stream, it's not a problem. Data streaming programming is very trending right now. If you are thinking about that, backend.js, React.js, all this kind of stuff are just streaming programming for JavaScript, for the browser. So when I say right now, a lot of people thinking about streaming as a way to program, it's not just for people like me want to build a backend for data. You have a lot of things you can do with streaming because you enhance the ability of the customer to have the data more quickly, and the application is more quick. It's more reactive. Just before the end of the talk, I want to thank Clementy, with basically the second part of my brain, and we work a lot together as the Iteratee. So part of the talk is a tribute to them. And we have some time for question, and thank you for listening. I put you a coupon for if you want to try the Clever Cloud. Thank you. I'm very sorry for the mess about PowerPoint. Some question? No question? Yeah? Yeah, I will push the source code of on GitHub. Yeah. At the beginning of the demo, sure. I'm not sure for the other part. I have to clean up some a magical part of me, but and I will push another source code. More interesting is I'm working with a team of Pli S3, working on the backend or S3, and I'm working on something where you are uploading a file. If you're putting the body parser, it uploads directly on S3 and give you a bucket file for your data management. So it's very interesting use case, and it will be on GitHub the next week. I have to kill a bug inside.